right, let's take a look at Chapter 3, Logic. In Chapter 3.1, we'll learn about statements, connectives, and quantifiers. We'll want to identify statements in logic, represent statements symbolically using 5 connectives, recognize the difference between the universal and existential quantifiers, write the negation of quantified statements. Statements in logic. In symbolic logic, we only care whether statements are true or false, not their content. A statement in logic is a declarative sentence that is either true or false. We represent statements by lowercase letters such as P, Q, or R. Examples of statements. Remember that to be a statement, the sentence must be either true or false. However, we do not need to know which it is. Examples. AIDS is a leading killer of women. If you eat less and exercise more, you will lose weight. In the last 10 years, we have reduced by 25% the amount of greenhouse gases in the atmosphere. Garth Brooks or Taylor Swift had the highest earnings in the entertainment industry in 2015. The following are not statements. Come here. This is not a declarative sentence. When did the dinosaurs become extinct? This is not a declarative sentence. This statement is false. This is a paradox. It cannot be either true or false. If we assume that the sentence is true, then we must conclude that it is false. On the other hand, if we assume it is false, then we conclude that it must be true. Note that all A through D fall into 2 categories: simple statements and compound statements. Simple statements containing a single idea were A and C. Compound statements containing several ideas were B and D. A simple statement contains a single idea. A compound statement contains several ideas combined together. The words used to join the ideas of a compound sentence are called connectives. The connectives used in logic generally fall into 5 categories: negation, conjunction, disjunction, conditional, and biconditional. Negation is a statement expressing the idea that something is not true. We represent negation by the symbol. That was not the symbol. Let's see. We represent it with the tilde. I'm not on the I'm on my, let's see, maybe I could do better than that. It's a tilde, nonetheless. All right. Maybe we'll actually see it on other screens. Negate each statement. R is the statement: the Retina display is included in the price of your MacBook. B is the statement: the blue whale is the largest living creature. The Retina display is not included in the price of your MacBook. We write this negation symbolically as tilde R. Tilde R. Oh, sorry, I'm using the mouse to write. It's hard. Or not pretty, anyway. The blue whale is the largest living creature. The blue whale is not the largest living creature. The symbols not B represent this statement. A conjunction expresses the idea of and. We use the symbol of a caret to represent a conjunction. Consider the following statements. P is the statement the tenant pays utilities. D is the statement a $150 deposit is required. A. Express the statement it is not true that the tenant pays utilities and a $150 deposit is required. Write this symbolically. And then also write the statement, maybe not P and not D. That's maybe what they want there. They've represented it with this colon. So that's a new notation. I'll assume it's not. Express the statement it is not true that the tenant pays utilities and a $150 deposit is required. When we write this symbolically, we'll write the negation of a set of parentheses, P caret D. So let's take a look. In this sentence, the sentence has the form P and D, right? But their negation symbol is this colon instead of the tilde. So these are a new set of slides for me, and that's either a new mistake that I've never seen before or a new notation that I've never seen before. Generally, the colon would be written as a tilde in our book. See, even here we see tilde, P, tilde, D. So the sentence has the form, I'll try to do these on the tablet so I can write better. The sentence has the form not parentheses P and D. And the symbolic form we were given before, where we assumed it was not P and not D, reads in sentence form, the tenant does not pay utilities and a $150 deposit is not required. We're using the problem-solving strategy of order matters because we had to do what was inside of the parentheses first and then negate it. So notice the difference in the forms of the statements in example 2 that we will show in this diagram. So A read negation of P and D, and B read negation of P and the negation of D. And the parentheses is important. Otherwise, you might read A as the negation of P and D and do it wrong. So these statements sound similar, but do not say the same thing. Keep in mind that changing the order of logical operations can change the meaning of a statement. Disjunction. A disjunction conveys the notation of or. We use the symbol of a V to represent a disjunction. Consider the following statements. H is the statement we will build more hybrid cars. F is the statement we will use more foreign oil. Use the following statement symbolically. Write the following statement symbolically. We will not build more hybrid cars, or we will use more foreign oil. This will be H with our connective with the shape of a V, and then the letter F. Oh, it's not build more hybrid cars. All right, so that's a tilde H or sign as a V and then the F. Which here, again, they're using this colon instead of the tilde. The conditional expresses the notation of if, then. We use the arrow to represent a conditional. Suppose that P represents the Phillies win the World Series and M represents Mayim will win an Emmy. We would read the statement P arrow M as if the Phillies win the World Series, then Mayim will win the Emmy. We would read it symbolically as if P then M, if P then M. We would write the statement if the Phillies did not win the World Series, then Mayim will not win an Emmy, symbolically as not P, therefore not M. If not P, then not M, where these colons represent negation. So just remember, these colons in our book is just the negation symbol. These are the same thing. Some books put an exclamation point as a negation. Just note to self. A biconditional represents the idea of if and only if. Its symbol is a double arrow. A polygon has three sides if and only if it is a triangle. Let P represent the statement a polygon has three sides, and let T represent the statement the polygon is a triangle. Then this statement has the form P double arrow T, which reads P if and only if T. Write each biconditional statement in symbolic form. The Blu-ray disc can be returned if and only if the seal is not broken. Let R represent the statement that the Blu-ray disc can be returned, and let B represent the statement the seal is broken. Then this statement has the form R if and only if not B. Quantifiers. Quantifiers tell us how many. Quantity is the root word. Quantities fall into two categories: universal quantifiers and existential quantifiers. The universal quantifiers are words such as all and every that state that all objects of a certain type satisfy a given property. Examples: all citizens over the age 18 have the right to vote. Every triangle has an interior angle sum of 180 degrees. Each NASCAR driver must register for the Daytona 500 by August 1st. Existential quantifiers. Existential quantifiers are words such as some, there exists, and there is at least one. The root word is exist, so there exists, existential quantifier. They're words that state that there are one or more objects that satisfy a given property. Examples: some drivers qualify for reduced insurance rates. There is a number who squares 25. There exists a bird that cannot fly. Negating quantifiers. Suppose we want to negate the statement, all professional athletes are wealthy. The word all indicates this is a universal quantifier. These Euler diagrams are showing us the group of wealthy individuals, and in A, we see that all athletes fall inside of the group of wealthy individuals. In image B, where we've negated, what we're looking at is some athletes have fallen outside of the wealthy circle, right? Outside of the wealthy group of individuals. So some athletes are not wealthy. Correct. Some athletes are not wealthy, or not all athletes are wealthy. Both are now existential. Incorrect. All athletes are not wealthy. When you negate a universal, you get back an existential. If you negate a universal and get back a universal, you have not done it correctly. Negate the statement. This one, existential. Some students will get a scholarship. So in our first Euler diagram, we see that the individuals getting scholarships and the individuals that are students overlap, and that some get a scholarship. Now, when we negate this idea, we see now that no student gets a scholarship. The correct way of saying this is no students will get a scholarship. So going from the existential to the universal. The incorrect way of negating this is to say some students will not get a scholarship. Going from the existential to the existential. That's an indication we've done it wrong. Also, some students will get a scholarship automatically implies some students will not get a scholarship. So no negation has happened if you've accidentally negated it with the last statement. The phrase not all here has the same meaning of at least one is not. The phrase not some are has the same meaning as none are. Negate each quantified statement and rewrite it in English. All customers will get a free dessert. Not all customers will get a free dessert. At least one customer will not get a free dessert. Some tablet computers have a 2-year warranty. Well, we can't say some don't because we already know that. So if some do and we negate this, then none do. So no tablet computers have a 2-year warranty. Solution to A. All customers will get a free dessert. We want to rewrite the statement, not all customers will get a free dessert, because the statement has the form, not all are. We can rewrite it as at least one is not. In English, we would say at least one customer will not get a free dessert. Some tablet computers have a 2-year warranty. The negation of the statement is it's not true that some tablet computers have a 2-year warranty because this statement has the form, not some have. We can rewrite it as none have. In English, we would say no tablet computers have a 2-year warranty.